Here I am back with another problem of work done, that is in module 2. First I'll be reading the question. To a closed system, 150 kilojoule of work is supplied. If the initial volume is 0.6 meter cube and the pressure of the system changes as P equal to 8 minus 4V, where P is in bar and V is in meter cube. Determine the final volume and pressure of the system. Now if you look at the first line, that is, to a closed system, 150 kilojoule of work is supplied. When we are dealing with work, it is very important to understand that when a system, suppose this is a system, when it gives out work, when it delivers work, it is taken as positive. And when a system receives work or when work is done on the system, that work is taken as negative. So, this is the sign convention, that is, work done on the system is taken as negative and work done by the system is taken as positive. For example, if we have a piston cylinder arrangement and suppose the gas entrapped inside the cylinder is pushing the piston outwards, that is, the piston is delivering a work. In that case, the work is taken as positive, and this work is also called the expansion work. Now, on the contrary, if the piston cylinder arrangement is operated in such a way that we exert a force on the piston so that the air inside or the gas inside the cylinder get compressed, then that work is a negative work. That is, it is also called a compression work, which is taken as negative. Now, keeping in mind, when you are doing any problem from work done, this is very important that the sign for work is to be applied in the proper way. Now here, to a closed system, 150 kilojoule of work is supplied. Therefore, in this case, the work done, W, the total work done, is equal to 150 kilojoule. Now, always when a value of work done is given, you need to verify whether it is a positive work or a negative work. In some cases, they will not be mentioning it in the proper way. After calculation, you will understand whether it is positive or negative work. But in this case, it is clearly mentioned. 150 kilojoule of work is supplied, work is given or supplied to the system, therefore it will become negative 150 kilojoules. Now, if the initial volume is 0.6 meter cube, that is, we are given V1, the initial volume, as 0.6 meter cube, and it is given that the pressure of the system changes by the equation P equal to 8 minus 4V, where the value of P is in bar and V is in meter cube. This is what is given in the question, and we are supposed to find what is the volume in the final case, that is the volume V2, what is the value and also what is the final pressure. This is what they are asking us. Now, how will we start the problem? So here it is clearly given. We are supposed to find the volume and the pressure. There is something related to work given and P given. So always connect this one, because we know that here to identify the process, whether it is a constant pressure, constant temperature, or adiabatic process, it is quite difficult. Therefore, we are going to apply the work done equation where work is equal to integral 1 to 2 pdv, because there is an equation in terms of p given to us. So I'm applying this work done W is equal to integral 1 to 2 pdv. Instead of or I am substituting the value of p there, which is 8 minus 4v into dv. Again, this can be written as integral 1 to 2 8 dv minus integral 1 to 2 4v dv. Again, that can be written as integral 1 to 2 8 dv becomes 8v in the range from v1 to v2 minus 4 v square by 2 again in the range from v1 to v2. So this becomes 8 into v2 minus v1 equal to 2 into, this is minus 2 into v2 square minus v1 square. This can be again written as 8 into v2 minus 0.6 minus 2 into v2 square minus 0.6 square. So now this equation become 8v2 minus 4.8 minus 2v2 square plus 0.72. That is equal to 8v2 minus 2v2 square minus 4.08. This I am adding, so that becomes 4.08. Now I am applying the work here. Work is minus 150 kilojoule, so I am multiplying it with 10 raised to 3 so that it becomes joule, is equal to 8v2 minus 2v2 square minus 4.08, this whole value into 10 raised to 5. Now why do we require a 10 raised to 5 here? Because it is mentioned that this equation P equal to 8 minus 4V, in that pressure is in bar or this value is in bar. Therefore we know that 1 bar is equal to 10 raised to 5 Newton per meter square. That is why I am multiplying it with 10 raised to 5. Now continuing, I am taking 10 raised to 5 here. Therefore this will be 150 into 10 raised to 3 divided by 10 raised to 5 is equal to 8v2 minus 2v2 square minus 4.08. So here it will be 10 raised to 2, and therefore this equation will become 150 divided by 100. Therefore it will become minus 1.5 is equal to 8v2 minus 2v2 square minus 4.08. Now I'll be reshuffling it so that I get it in this format. That is, this 2v2 square I will bring it to this side, so it becomes 2v2 square minus 8v2. This I have brought this side. Now 4.8 when it comes to this side plus 4.8. So it will be plus 4.08 minus 1.5. So again my quadratic equation become 2v2 square minus 8V2 plus 2.58 is equal to 0. Now I have a quadratic equation in terms of V2. Therefore, I am going to solve this by using the equation. We know that x is equal to minus b plus or minus root of b square minus 4az by 2a, or you can use calculator to directly solve it, but I am just using this equation in case you don't have a calculator with equation. So here we know that if I take this equation, here x is equal to V2, b is equal to minus 8, a is equal to 2, and c is equal to 2.58. Because in a quadratic equation is ax square plus bx plus c equal to 0. That is, this is the solution of a quadratic equation. So when I am solving this one, I get V2 is equal to minus b means minus of minus 8 plus or minus root of b square minus 4az divided by 2a. 2 into a is 2 into 2, that will be 4. Now you find the value of b square minus 4az. You can easily find the value of b square minus 4az, and the value of b square minus 4az will be equal to 6.584. Therefore, V2 is equal to either minus of minus plus 8 plus 6.584 divided by 4, which will be equal to 3.646, or V2 is equal to 8 minus 6.584 divided by 4, which will be equal to 0.354. So we have two values for V2. Now the initial value, that is, check what is the value of V1. You can see that V1 is equal to 0.6 meter cube. So can V2 be 3.646? That's the first question. We have taken work as minus because work is given to the system. That means there is a compression process happening. Therefore, volume can never increase from 0.6 meter cube to 3.646 meter cube. Therefore, the only possibility, this possibility is not there. Therefore, the only possibility is that the volume can become 0.354. This is very clear. Whenever you solve problem like this, just look at what is happening, whether V1 or V2 can increase or decrease, and based on that you will get the final answer. And here we are sure that the final volume, which is V2, is equal to 0.354. Now, what is the final pressure? How will you find the final pressure? The final pressure P2 is equal to, you have an equation here, you have the equation, right? This is the equation 8 minus 4V. Therefore, I'll apply that one, that is P2 is equal to 8 minus 4V2. V2 is there, which we have just found out. Here, the value of P2 that you get will be in bar, because the value of P, as we have told, it is in bar. If you want to convert this into Newton per meter square, just multiply it with 10 raised to 5. So this is the solution.